Sorry. Yeah.
First, thank you for the presentation. Very interesting. I myself work on Hebrew in my thesis, so it's close to my interest. And I would like to ask, first of all, you talked about the document, that the Hebrew tree bank. Yes, I wrote it in the chat. Did you already annotated the document level separation?
Yeah, we have it. Yeah, it's actually available freely on GitHub. I will post the link. Yeah.
Cool. And also, so you in Hebrew, the plan is to annotate name entity recognition and all the morphology I saw. And
yeah.
do you know if you're going to follow Nemo, for example, or something else? Or
we adopted
not yet decided.
Sorry, go ahead.
No, I just want to ask if it's not yet decided. It was like that.
We adopted some of the decision taken in Nemo. We are going to create our own scheme, and we are going to publish it as well. Let me also note that for academic purposes, you can use our data. So already 2 academics in Israel are using the data for the research. So that's part of the idea of this consortium. I will link to the GitHub that where we have yeah.
Noam, you can.
Thank you very much.
Noam, you can put the link of our website with the previous lecture of Amir, which has the link to GitHub, so you can see the lecture about the HTB.
Any more questions before Nick is going to talk?
I have a small question, if I can, if I might. Have you considered looking at the movie translation, movie subtitles that are both in Hebrew and in Arabic as a database for in which they compare?
Okay, so the subtitles have an interesting artifact in Arabic that there is an elevation of the language. So what we do deal with subtitles, but they try to make the language more standardized. It's actually an interesting exercise to collect enough data, correct it, and then have a parallel corpus of spoken Arabic and written Arabic. And that's partly what we are going to do in the way we are going to transcribe some TV programs broadcasted in Arabic where people speak in their own dialect, and where we also have access to the subtitles. So we are going to have such a corpus, and we are going to use subtitles. What will be very interesting is to see if at some point we can actually massage the data of the elevated language, השפה המוגבהת, כן, שיש בכתוביות, and to kind of translate it to Amir, to the vernacular spoken in different areas.
I see, thank you.
Welcome. Okay, if you have more questions, we can post them in the end, and I think Nick wants to get rid of this stuff, so go ahead, Nick.
Definitely. Thanks everyone for having me. Let me see if I can find my talk now. This is it. You can see that?
Yeah.
Okay, great. So I'll just jump right into it. This is about our QA process and how we can make this more efficient, and how we can feel more confident about the output of our annotators and the consistency of our releases and improve the quality of the models that we're using. So first, I'll talk to you a little bit about our annotation guidelines. I'm going to say things very as well as our annotation pipeline. This should say pipeline here. After that, I'll talk to you a little bit about the validation tools that we are using and what sort of challenges we ran into when developing them. And then I'll talk to you briefly about what sorts of really interesting ideas that we're beginning to integrate into our system. So the annotation pipeline. I don't remember how much Noam talked about this, but we use a project called Arburator GRU, which is out of France, and it consists of three layers. At the furthest back, the most back end of it, we have GRU, which is an OCaml search engine for trees. So it's not expected necessarily that you're using conlu, but that is, of course, the most popular use for it. So GRU has its own query language, and in fact, allows for transformations. So you can actually write expressions in GRU's language, which searches for trees and modifies them. I'll discuss that more later. That's going to be key to some of the more interesting validation and quality assurance we can do. There's a front end, which is JavaScript based. And here's a little screenshot of what it looks like. You've seen also some screenshots from it in Noam's presentation. And the backend, which is a Python based system that manages, it basically just mediates between the front end, which is lots of JavaScript, and the backend, which is lots of which is this tree database. So there's three interfaces here, meaning there's three opportunities for an impedance mismatch. So if you're really good at counting, you know that between three objects, there are only two interfaces, right? If you have them stacked on top of each other. Anybody guess where the missing interface is? So above the Arburator front end is the person entering data into Arburator. So there's the third interface. So we have the human Arburator interaction. We have the Arburator interaction going from front end to back end. And then we have the Arburator GRU interaction. And at every point here, there's the possibility for something to go wrong. And sure enough, things go wrong everywhere. So let me talk to you a little bit about what's guiding these systems. So the annotator front-end interface is governed by guidelines written for humans. So Noam talked a little bit about this. We have an enormous amount of guidelines written for humans. These include prose descriptions, and it assumes that the reader is able to make inferences and to make clever leaps of imagination. But it also assumes that the reader has amazing memory and attention, and that they're never going to make a mistake or forget a guideline or anything. And so definitely our annotators are intelligent, but whether they have perfect memories and attention, I'm sort of skeptical of this. And because of that, we see occasional variation in our annotated data, which is, of course, the purpose of our QA process. The front-end back-end interface is a complex system. So it consists of a bunch of JavaScript libraries that perform serialization, parsing and serialization of the conlu text format, and there's bugs everywhere. So here's the Git log. And in fact, I took this opportunity knowing that many of our annotators are on this call, and this actually grew a little bit longer while Noam was speaking. And I took the opportunity that some of the annotators weren't using the annotation system and pushed some fixes to it, which of course requires a restart and a downtime of about 3 minutes, which you don't want to catch an annotator while they're in the process of saving a tree with that. This, by the way, the alternate title of this talk might be how to make all of your annotators angry at you. So the backend, the Arburator backend to GRU interface is extremely simple. It's just calling it a library is much too respectful to it. it's just a simple wrapper of Brew's REST API. There's no error processing. And there are minor bugs in round trip, which we haven't even bothered to fix yet. They're just, they don't really cause too much interference. Anytime that happens, we just fix it manually. So in summary, there's a lot of interfaces here. There's little to no validation done anywhere. At least that was the initial state of the system. And there can be problems introduced at any level. Can be and are introduced at any level. Some of these, we're lucky, and they're caught after the first time they try to go across an interface. This usually is the source of lots of tickets on to track. And I try to fix them as quickly as I can. And the annotators complain immediately. Some of them are only noticed after passing through several of these layers, though. And sometimes the error isn't passed back down, or it's passed back incorrectly. And then you have annotators complaining that not only is the system not accepting their tree, but they don't know why. They don't even know what it is that they've done wrong. So the solution is to tighten the validation. So we've fixed over 20 bugs in the front end so far, and I added a validation hook at this front end back end interface. And so now the task in front of us is to design and implement useful plugins for this hook. So things that will tell our annotators useful information to help them, that will catch more errors so that they don't get caught at QA or, heaven forbid, released to the general public. So the faster we can catch these, the less work we have to do. And also, we want to be feeding our annotators useful information. We want to tell them in the most efficient way possible what the system doesn't like. So I'll discuss those validation tools now, unless there are questions. Okay, so going back to, I don't know, August maybe, our validation, we had a validation script, an easy to read Python script developed by one of our annotators. And it has about 20 common errors that it detects. It corrects some of these, which is more than I can say for the rest of our system so far. And it also identifies some probabilistic errors, some situations which are likely to result in error, but not guaranteed. And it was run by hand during the QA process. So this is after all of the annotators have submitted all of their sentences for a batch. We split our annotation up into batches. The QA process would be run on that batch. And that included an automated part, which is this internal script, as well as manual review. When we understood that we needed to move this validation into the annotation process, so that annotators were not even allowed to submit incorrect trees, incorrect annotations, we turned to the official universal dependencies validation script. So this is an extremely convoluted Python script used for
I hope it's my internet that went down, not Nick's, but I see some
no,
places.
It's Nick.
No, it's not.
Nick, I think.
it's Nick, yeah.
Yeah. Well, you said the official title could have been how to make annotators angry, and that's what happens when you do that. So we have some hackers in the team.
So if he doesn't come back in a minute, maybe we go to the next presentation until he comes back, and then he can.
Yeah. Okay. Maybe maybe Yousef, can you present, and hopefully Nick will join us to the more interesting part of his talk.
So just make another file.